Hello my dear students. Today we are going to discuss about the numerical problem of clutch, especially single plate clutch. This is the simple numerical problem. We have to solve this numerical problem systematically. A single plate clutch with both side effective has outer and inner diameters 300 mm and 200 mm respectively. The maximum intensity of pressure at any point in the contact surface is not to exceed 0.1 Newton per mm square. If the coefficient of friction is 0.3, determine the power transmitted by the clutch at speed 2500 rpm. So now we will start this to solve this numerical problem. First of all, we have to write the given data. So this is the given data. N is equals to 2 because N is the number of pair of contact surfaces for the single disc clutch. N is equals to 2, and this is the diameter for this is outer diameter and inner diameters, and these are already given in the question. And 300 mm, that means we have to calculate the value of R1, that already half 300, that means R1 is 150 and R2 is 100, and maximum intensity of pressure, that is equals to 0.1 Newton per mm square, and coefficient of friction is equals to 0.3, and the speed is given 2500 rpm. So now we have to calculate the value power transmitted by the clutch. So power transmitted by the clutch, P is equals to T omega, or we can say that P is equals to 2 pi nt upon 60. Here, if we will get the value of the T, then we will have the value of power. So first of all, we have to calculate the value of torque transmitted by the clutch, and torque transmitted by the clutch T is equals to, we know that, N mu W R. So this is the torque transmitted by the clutch. We have already derived this derivation in previously. So here the value of N, that is equals to 2, mu, that is equals to 0.3, and now we have to calculate the value of W, axial load transmitted to the clutch, and the mean radius for uniform wear theory. So here the load transmitted to the clutch W is equals to 2 pi c R1 minus k R2, as we know that. And but here you can see that the new term is new term C comes. And what is the value of the C, and how we will calculate the value of C? We have already discussed in the uniform wear theory the P, maximum intensity of pressure into minimum radius, that is equals to C. What is the C? C is a constant. So this is the P max into R2, that is equals to C. So from here we will get the value of C. So now we have the we already have the value of maximum intensity of pressure P max, that is equals to 0.1 into R2, that is equals to 100 mm. So we will have the value of C, and substitute this value in the equation load transmitted to the clutch. W equals to 2 pi c R1 minus R2. So substitute this value in place of C, and also substitute the value of R1 and R2 from the given data. Now we will have the value of W. So we will put the value of W in the equation torque transmitted by the clutch. So torque transmitted by the clutch T is equals to N mu W R. So now we will have the value of N, mu and W also. Now we have to calculate the value of R, mean radius, that is R. So R for uniform wear theory, that means mean radius for uniform wear theory, R is equals to R1 plus R2 divided by 2. So this is the value of R, R1 plus R2 divided by 2. So we will have the value of R1 and R2 both, say, so see the 150 and 200. So 150 and 200, that is 250 divided by 2. So we will have the value of capital R. So substitute all the values in this equation, and we will have the value of torque transmitted by the clutch. And now the substitute the value of torque transmitted by the clutch in the equation, power transmitted by the clutch. So we will have the value of power transmitted by the clutch, that is equals P, that is equals to 61.693. So guys, this is the simple numerical problem, and this is the procedure for solving the numerical problem. So thank you very much.